Session 8.2 Testing a claim about a proportion. Testing a claim about a population proportion. For the session 8.1, we introduced about the null and alternate hypothesis, the test statistic, p-value method, critical value method, and also how to draw the final word conclusion. And right now for these sessions, we're going to combine everything together and we want to do the hypothesis testing about a population proportion and use a normal distribution as an approximation to the binomial distribution. Normal distribution will be using the table A2, the Z distribution. Requirement: the sample observation a simple random sample. Simple random sample. And then condition for binomial distribution are satisfied. This is talking about for the chapter 5, we have the binomial distribution. Remember, we have the 4 requirements. We have a fixed number of trials, 2 outcomes, success and failure. And probability remain the same. And also, each trials are independent. So these 4 requirements will apply for this hypothesis testing for population proportion. And also, we do have the condition n times p greater than or equal to 5. The n talking about the fixed number of trial. And then the p here, this is the population proportion. So when they multiply it, they have to be greater than or equal to 5. This is just want to make sure you have the larger sample size in here. And n times q greater than or equal to 5. The Q here, that will be the population proportion in failure. So P and Q, that will be the complement. So when you multiply the sample size, it has to be greater than or equal to 5. So this is going to be the requirements. Okay, notation. I need you guys remember all this notation. The N here, talking about the sample size or number of trials. P hat, this is the sample proportion. We have the P here. This is the population proportion in success. P hat, that will be the sample proportion in success. Sometimes they will be given for the sample proportion, but sometimes you need to use the formula to figure out what is your sample proportion. And that will be the X over N. The X talking about the number of success. So number of success divided by the sample size, that will be the sample proportion. Okay, P, that will be the population proportion. Q, that will be the population proportion in failure. Again, P and Q, that will be the complement. So starting from chapter 8, you guys need to remember all this notation. Okay, when you see the P hat, you need to know this is the sample proportion. And you need to know how to find out the sample proportion. Okay, performing a hypothesis test for a proportion using the p-value method. We have 2 parts in here. First part, we're working on the hypothesis testing for proportion using the p-value method. Second part will be using the critical value method. First, verify the requirement. And then you're gonna see there are X steps from here. And we'll be using this X step from now on for chapter 8, chapter 9, chapter 10, chapter 11, and chapter 12. If you guys understand the concept for the chapter 8, it will be easier for you guys to learning for chapter 9, 10, 11, and 12. We'll be working on this X step here. So you're gonna see the original claim. Okay, we learned this number 2 and number 3 from the session 8.1. Okay, original claim statement. So we are working on 4 population parameters, either population proportion, population mean, population standard deviation, or population variance. For this session, session 8.2 will be focused on the population proportion. So when you guys working on the claim statement, make sure only with the claim statement. Translate it from English to mathematical equation. After you figure out the original claim statement, look for the formula. For each population parameter, we do have the formula for the test statistic. So for the population proportion, we do have the formula for the test statistic. That will be the p-hat minus the p divided by the square root of p times q divided by the n. Remember what is a p-hat again? This is the sample proportion, population proportion in success, population proportion in failure, and then also the sample size. Okay, one more time. After you know you're working on the population proportion, find out the formula for the test statistic. Write it down for the number 4. And then, based on the formula here, we need to find out the sample size n. So write it down for the number 1. Find it out the p-hat sample proportion in success, the p population proportion. Find out the q as well. You should get all this information from the questions. Okay, now you're gonna write down your null and alternate hypothesis. For the null hypothesis, you do have a free choice, either equal to, less than or equal to, or greater than or equal to. Okay, this is gonna be the choice for your null hypothesis. And then for the alternate hypothesis, you can have a not equal to, strictly greater than, or strictly less than. And null and alternate hypothesis is always like a pair. Okay, this is a complementary. So figure out the null and alternate hypothesis. And then determine which tail test is it. If you are working on not equal to, that will be two-tail test. Strictly greater than, right tail. Strictly less than, that will be the left tail test. Okay, now distribution. I want you guys to sketch the graph in here. This is the p-value method. First, we are working on the z distribution. So z distribution, we will have the normal distribution. And I just used the left tail example. Okay, left tail example here. So first, after we figure out the test statistic, you're gonna write it down from here. Okay, this point, that will be your test statistic. You find it from the part 4 here. And we want to use the p-value method. So we want to use your test statistic to figure out what is your p-value. P-value will be the area of the left tail. Okay, like here. After you have this picture, okay, number 6, p-value. If they given the test statistic, how can you find the area? You'll be using normal CDF, right? Normal CDF, lower value, and the upper value. Use the calculator, figure out what is the p-value. And after that, step 7, you need to draw the conclusion about the null hypothesis. You want to reject or fail to reject. So, if your p-value compare with your significance level, that's a less than or equal to, you're gonna reject. Strictly greater than, that will be fail to reject. Okay, and then final works, we're gonna use the chart in the session 8.1 from the number 1, 2, 3, 4 conclusion. So this is the step how you guys perform your hypothesis testing for the population proportion using the p-value method. And after you're done, you could use your calculator to double check your work. I'm gonna cover this part after we have the first example. Okay, example 1. In the 2009-2010 American College Student Survey, 90% of female college students rate the social network site Facebook as cool. Assume that the survey was based on a random sample of 500 students. A marketing executive at Facebook wants to advertise the site with the slogan, "More than 85% of female college students think Facebook is cool." Can't you conclude that the proportion of the female college students who think Facebook is cool, that is greater than 0.85? Use the 0.05 level of significance. Okay, so for this question, first think about it. Which population parameter you are working on it? Are you working on the proportion, the mean, standard deviation, or variance? You can see this is working on the proportion, right? Or the given information, they never mention about the mean or standard deviation. So that will be the proportion problem. First step, verify your requirement. So we have a simple random sample and we have two outcomes. Either they think Facebook is cool or think Facebook is not cool. Okay, two outcomes. So Facebook is cool, this is considered number of success. Facebook is not cool, this is talking about the failure. Okay, verify the n times the p. The n talking about the sample size, we have a 500 students. Times the p, this is the population proportion in success. So we have a 0.85 in here. Multiply it, you're gonna see both of them is gonna be greater than 5. Okay, we're gonna do the first 4 steps here. Number 1, extract information. But first, I want you guys figure out the original claim here. You know this is working on the proportion. So first, find out your claim statement. Which sentence will be your claim statement? That will be here, right? Can't you conclude that the proportion of the female college students who think Facebook is cool, that is greater than 0.85? Okay, just translate this English to mathematical equation. So we have the proportion greater than 0.85. And then figure out the null and alternate hypothesis. When you have a strictly greater than, that will be the null hypothesis or alternate hypothesis. That will be the alternate hypothesis, right? Strictly greater than. Now, figure out your null hypothesis. That will be opposite with this guy, right? So that will be less than or equal to. Okay, determine left tail test, right tail test, or two tail test. This is strictly greater than, right? So that will be right tail. Write it down, this is the right tail test. Okay, find out the formula for the test statistic. We'll write it down here first. And then figure out the extract information here. Okay, I want you guys find out the significance level. I want you guys find out the level of significance also. So with the questions here, figure out these 5 guys. Okay, and that will be the sample size. We have the random sample of 500 students, so 500 here. Okay, sample proportion. Okay, sample proportion. Look at the first sentence here. This is gonna be the survey. 90% of female college students rate the social network site Facebook as cool. So this 90% talking about the sample proportion. So we have a 0.90 here. And then the P, this is the population proportion. You always look at the claim statement here. Okay, this is always equal to the number with your original claim. If this is a 0.85, this is going to be 0.85. And then the Q here, that will be the complement of P. So subtract from 1 here. You could get 0.15. Significance level, we're going to use 0.05. Okay, after that, plug it in to your test statistic here. Okay, plug it in. You're gonna see this. Make sure you put the preference when you guys use your calculator. Okay, you should get 3.13 here. Okay, 3.13. Let me show it to you guys how to use your calculator here. Okay, 0.9 minus 0.85 close parenthesis. And then divided by square root is going to be second x squared here. So I have a 0.85 times 0.15 divided by 500. Okay, make sure your square root is going to be covered the whole thing in here. And then enter. You should get 3.13. Okay, 1 to 2 decimal space. So this is a 1 less than 5. You're going to replace by the 0. So that's a 3.13 here. Try to put everything on your calculator instead of do it like one by one, okay? Okay, number 5, distribution. So we are using the z distribution. We have the normal distribution with the y-tail test. Okay, remember here, that's a y-tail with the z. So I have a normal distribution with the y-tail. And then this point, that will be equal to your test statistic, which is going to be 3.13. Okay, we are using the p-value method. So we use the test statistic, figure out what is your area of the y-tail. Okay, this is going to be equal to your p-value. So use the test statistic to find out the area of y-tail. So we're going to use the normal CDF. Lower value will be 3.13. Upper value, 1E99. Use the calculator. Okay, you should see 8.74 times 10 to the power of negative 4. When you're using the normal CDF, you're going to do second vast. Choose number 2 for the normal CDF. So lower value, that will be 3.13. Enter. Upper value, that will be 1. Use the E with the comma, this one. Don't use the sign with the E here. So use the comma. I'm going to do second comma 99. Okay, enter. This is a standard normal distribution, so mean equal to 0, standard deviation equal to 1, and go to the place, enter. Enter. So you're gonna see my answer here, that will be 8.74. Don't just write down the 8.74. At the end here, there's a E negative 4. Okay, this is the scientific notation, E negative 4. So when you write it down, make sure you put 8.74 times 10 to the power of negative 4 here. And this is a negative. So you're gonna move your decimal space 4 space to the left. You should get this guy, 0.000874. The value is really, really small. So we have the smaller p-value here. I wanted to the 4 decimal space. This guy's greater than 5, so I'm gonna add 1 from here. This is how you guys figure out your p-value. Okay, now you want to use the p-value compare with your significance level. So the p-value will be equal to 0.0009 compare with your significance level. So this should be less than or equal to or greater than. That will be less than or equal to, right? Less than or equal to the alpha. So when it's less than or equal to, you're going to reject the null hypothesis. Okay, last one. The final work, you're going to use the chart section 8.1, the 1, 2, 3, 4 conclusion. So you're going to go back to look at your original claim. This is going to be greater than, and this is going to be go to your alternate hypothesis, right? Go to the alternate hypothesis. So look at the chart in the section 8.1. If your original claim, go to the alternate hypothesis. Okay, you're going to go on like this way. So either number 3 or number 4 conclusion. And then you're going to reject the null hypothesis. So the original claim has the alternate hypothesis, and then we're going to reject. So reject, that will be like this one. There is sufficient evidence to support the claim that, and then copy the original claim statement. Okay, so we're gonna write it down. There is sufficient evidence to support the claim that more than 85% of the female college students think Facebook is cool. Okay, one more time. I need you guys write your conclusion with the complete sentence. Okay, complete sentence. You don't put number 3 conclusion in here. You don't just stop it to support the claim and put the period T. I need you guys write down the claim statement on the homework and the exam. So this is how you guys using the p-value method to perform the hypothesis testing for population proportion. Okay, let's try another example. I want you guys to do it by yourself. First, figure out the original claim, null and alternate hypothesis, the left tail, right tail, two tail test. Write down the formula for the test statistic and figure out for the number 1 the extra information. Let's check the work. First, original claim. Find out the claim statement. Which sentence is gonna be your claim statement? There will be test the claim that in the population of all senior executives, 45% say that the most common job interview mistake is to have a little or no knowledge of the company. So this is gonna be your claim statement. You know that we're working on the population proportion. Do they mention about less than or greater than? No, right? So we will be saying P is going to be equal to 0.45. Okay, figure out the null and alternate hypothesis. The equal sign, this is going to be go to the null hypothesis. What is the alternate hypothesis? It's going to be opposite with this guy, right? So it's going to be not equal to. Okay, left tail, right tail, or two tail? That would be two tail. Okay, write down the formula and figure out these 5 guys here. So what is your N, your sample size? That will be in a survey of 155 senior executives. So this is going to be your sample size. Sample proportion, 49% say that the most common job interview mistake is to have little or no knowledge of the company. So this is going to be your sample proportion. And then the population proportion, they'll be using the claim statement in here, right? So that'll be 0.45. Okay, Q, that'll be the complement with the P. So subtract from 1, you could get 0.55. And then significance level given is 0.01. Okay, now plug it in here and use your calculator to figure out what is your test statistic. Okay, you should have this one. Make sure you put the frequency on the top when you guys use your calculator. You should get 1.00. This is gonna be your test statistic. Okay, number 5, we're gonna do the distribution. We do have a two-tail and that's a z-distribution. So we have a normal distribution and the test statistic is z equal to 1 is gonna be here. Okay, so we're gonna figure out what is the area of the whitetail. Use the test statistic, figure out the area of the whitetail. So normal CDF, lower value to the upper value. And you're gonna multiply by 2 because you have a two-tail. Okay, when you use the normal CDF 1 to 1D99, you only figure out the area of the whitetail, but the p-value method, the two tails here will be your p-value. So you need to multiply by 2. So you should get this guy, 0.3173. Okay, compare with your significance level to 0.01. This guy should be greater than or less than or equal to. It should be greater than, right? Greater than the significance level. So it's greater than, we're gonna do fail to reject the null hypothesis. Okay, conclusion 1, 2, 3, 4. We have a fail to reject. So go back, look at your original claim. This is equal to, so this is gonna be go to the null hypothesis. Okay, they're exactly the same thing. So go to the null hypothesis. So either number 1 or number 2 conclusion. Okay, number 1 or number 2 conclusion. And then you have failed to reject. There is not sufficient evidence to warrant rejection of the claim. Okay, number 1, number 2 conclusion, that will be warrant rejection of the claim. And then copy the claim statements here. Okay, your calculator here. Click on the step, use the arrow button, go to the test. And we are working on one population proportion, C distribution, hypothesis testing. That's a 1 in here talking about the one population. On the chapter 9, we do have a 2 population. Okay, this is a chapter 8, so we're gonna use number 5 here. And that's the population proportion. So we have a 0.45 in here. Okay, number of success. Do we have the number of success in here? So how can we figure out the number of success in here? We only have the sample proportion, right? We never mentioned about the number of success. But remember, we do have the sample proportion formula. So we have the formula here. We don't know about the x, but we know the sample proportion and also the sample size. So plug into this formula. And we just multiply 155 for both sides here. Use your calculator. You should get 75.95. We round it up. It should be 76. Okay. So go back to the calculator here. We have a 76 for the number of success and sample size 155. And the next one here, this is talking about your alternate hypothesis. So my alternate hypothesis, we have a not equal to. So we're going to use the not equal to. And then go to calculate. So first, this is going to be your alternate hypothesis, the proportion not equal to 0.45. And then we have the test statistic, 1.009, and we only get 1.00. It is because our sample proportion, we are using the 0.49, but when we're using the formula, we want up a little bit for the number of success. So that's why it's gonna be a little bit off for your Z in here. We just keep what we have from here. And then that's a P here. This P, this is for your P value, okay? One more time. This is an alternate hypothesis not equal to 0.45. Test statistic, and the P here, that will be the P value. So double check, you got the P value 0.3173. Okay, 0.3173. Here we got 0.3129. Again, we do have a little bit off because when they calculate the p-value on your calculator, they use more than 2 decimal space for your test statistic. But they should be really, really close to what you guys get from here. Okay? So we do 2 examples using the p-value method for the hypothesis testing for population proportion. Right now, I want to use the same example, but we are working on the critical value method. Okay, performing hypothesis test for a proportion using the critical value method. So first, verify the requirement. So you can see we still have the X step for the critical value method. The only difference is number 4, 5, and 6, they have a different order with the p-value method. So how do I know we'll be using the p-value method or critical value method? You will see the critical values here, means I want you guys to use the critical value method. If you're gonna see the step 6 here, this is saying p-value, means I want you guys to use the p-value method. Okay, again, figure out original claim, find out the test statistic formula, figure out the extract information, write down the null and alternate hypothesis. Okay, the number 1, 2, 3, 6, that's exactly the same way with the p-value method. Only difference is going to be the distribution, critical values, and the conclusion. Okay. Okay, for number 4, we're going to do the distribution. So we are using the left tail example again. For the critical value method, remember what is the area of your left tail. Critical value method, when you have the left tail example here, this is going to be equal to your significance level. Use the significance level to find the critical value. So how can you find your critical value? You're going to use the inverse norm. Area from the left to figure out what is the critical value. You're going to see the value here. That's an S in here. Remember, when we're working on the left tail, your critical value will be negative. If you're working on the right tail, your critical value will be positive. If you guys working on the two tail, means you have a 2 critical values, one positive and one negative. Okay, after you figure out the critical value, you should know about the test statistic. Then you're gonna look at the test statistic. If your test statistic in the critical region is talking about here. If your test statistic located in the critical region, we reject. If your test statistic is not in the critical region, here this part means not in the critical region, so that will be fail to reject. Final words, use the chart intersection in point 1, 1, 2, 3, 4 conclusions. Okay, let's redo the example 3. This time we'll be using the critical value method. So on the notes, I should give you guys everything like here, right? This is we cover it from the example 1 already. Okay, exactly the same thing for step 1, step 2, step 3 here. And then distribution. We are working on the Y tail. So we have the Y tail with the normal distribution. Okay, first, what is the area of the Y tail? That will be equal to your significance level, right? So that will be 0.05. If you know the area of the Y tail is going to be 0.05, what is the area from the left? You're going to subtract from 1, right? Total area under the curve is 1. So 1 minus 0.05, which is going to be 0.95 here. Okay, critical values. We're going to use the inverse norm, area from the left, use the calculator. You're going to get 1.645. And it makes sense, right? Because we have the Y tail. The critical value here should be positive. Now, figure out the test statistic. Plug it in. You should get 3.13. Okay, now draw the conclusion. We are using the critical value method. So look at the test statistic. Where is your test statistic located? Should be in the critical region or is not in the critical region? So 3.13 is greater than 1.645. So we believe that the test statistic is located somewhere like here. Okay, draw the conclusion. If the test statistic in the critical region, we're going to reject, right? Because the test statistic located in the area of the alternate hypothesis. So we're going to reject the null hypothesis. Okay, conclusion. Same thing. We have the original claim go to the alternate hypothesis. So either number 3 or number 4 conclusion. And then we have the reject. So it's going to be number 3 conclusion. There is sufficient evidence to support the claim that more than 85% of the female college students think Facebook is cool. Okay, I want you guys to remember that on the homework and exam, I need you guys show me like this picture. Okay, I need you guys show me where is your test statistic located. Okay, don't just show me this is a 0.05 and that's it. Show me your what is your critical value. Show me where is your test statistic located in the homework and also the midterm. Okay, example 4. The first 3 steps we already covered in the example 2 already. Right? You should find this part on your notes already. So we start working on the distribution. We have a 2 tail with the z distribution. So we have a normal distribution with 2 tails. And we know the significance level is going to be 0.01. So first, figure out what is the area of each tail. You're going to divide it by 2 here, right? So it should be 0.005. Okay, figure out what is the critical value in here. We'll be using inverse norm, area from the left. So you should get negative 2.576. And again, we have a 2 tails. So we should have a 2 critical values. So it should be 1 positive and 1 negative. Okay, 2 tails, so you have a 2 critical values. And then find out the test statistic. You should get 1 here. Okay, now show me where is your test statistic located. Should be in the critical region or is not in the critical region. It should be is not in the critical region, right? This is called is not in the critical region. So the test statistic is not in the critical region. We're gonna fail to reject, okay? Fail to reject the null hypothesis because your test statistic is located in the null hypothesis here. So we say fail to reject. And then conclusion, that will be the number 2 conclusion, not sufficient evidence to warrant rejection of the claim. Okay, one more time. When you guys working on the critical value method, I need this picture. Okay, show me what is the area for each tile, what is your critical values, and where is your test statistic located. That's it for the session 8.2.